Hello, welcome to today's webinar. As you can tell, we've been having a few technical difficulties, but I think we restarted it. I think we're good now. You should be able to hear us. So thank you for sticking with us here. So today we're talking about creating a coding generation. My name is Brandy Brown. I'm the Director of Marketing at Hand to Mind, and I'll be your moderator today. Appreciate you guys sticking with us, taking time out of your busy schedules to spend time with us. We're going to cover quite a few things today. Our favorite reasons to teach coding, an approach to teaching coding that ranges from an early age all the way up, some ways to apply it to the real world, and then finally how STEM in action from Hand to Mind can tie it all together for you in the classroom. What you may not know is that by being here today, you are entered to win a STEM in Action kit of your choice. So stay tuned. We're going to draw that at the end, but you must be present to win. So we will get back to that shortly. All right, so let me just, after our technical difficulties here, let me walk you through the control panel on the side. So some of you guys have already found the question section and were able to give us feedback that you weren't hearing us, so thank you. We love that interaction. Please continue to ask those questions. We want to have interaction throughout. We'll stop throughout to answer some of them, so keep submitting them there. You should hear us now. If you don't, you can, if for some reason your computer has any issues, you can always call in through the phone call, and our webinar is being recorded. We already did the polls and had some feedback from you guys. Most of you are kind of in the middle where you're kind of dabbling in coding. You want to learn more. We love that. We are going to be asking you for feedback of how are you dabbling? What are you using in the classroom? So stay tuned for that question we'll want feedback on. And then it was kind of a mix for what you guys were here for. About half of you were here for your own classroom and wanting to use things in your classroom, and then about a quarter each were here looking for maybe your team or your district. So just an idea of who's on the call and the kind of feedback and resources we have here, because it's all about that community. Lastly, there are some upcoming webinars I want to let you guys know about in October. On the 23rd, we are having a webinar, Unlock Numeracy with Daily Math Fluency. You can use this bit.ly link to register for that. And then Closing the Gap with Hands-on Literacy will be October 29th. So excited to continue the webinar series that for the fall here. All right, now on to the good stuff. I am so excited to turn this over to Becky McDowell. She's the Director of K-8 Science for Niles Township in Illinois. I have known her for some time now. She is a speaker at NSTA, NCTM. She's spoken at Google Summit, speaks across the country, and now virtually, which we totally appreciate. She has been a classroom teacher. She's also been on the Hand to Mind side and worked as a product development manager. She was actually one of the developers of STEM in Action. So she has a really unique point of view, not only as kind of that background as to why we developed STEM in Action, but she's actually using STEM in Action in her district now, so she can kind of talk about both sides of that, which is super awesome. So with that, I want to hand it over to Becky. Becky, the floor is yours.
Thanks, Brandy. Glad we were able to figure out the sound. Very important, so thank you for sticking with us, like Brandy said. So I just transitioned into a administration role, so as Director of K-8 Science, and I'll tell you more about my districts that I work with at the end of the session, kind of a case study, but I just came from the classroom. So the last 4 years was a K-5 STEM teacher, teaching lots of robotics and coding. And so this is a big passion of mine and something I speak on quite often. So I'm actually going to be presenting at NSTA in Salt Lake City and Seattle, if you guys are going, or FETC in Miami. You can find me at any of those conferences coming up yet this year. So overall for today, what we want to talk about for our goal, Brandy, you want to switch the slide there, is that no matter what kids are interested in, what field, our future is technology. It includes technology in every aspect, and coding is increasingly part of that. So everything that we're going to be doing and the problems, the global challenges of clean water, enough food, climate change, exploring our Earth and space is moved forward by computers and coding. And so we need our young people to understand that language and be those problem solvers, building those skills and confidence. And so our overall agenda for the day, what we will cover is that why, right? Why is it important? Why do we start so young? Why not just high school? As well as, well, if you don't have the access to one-to-one technology or the budget for robots, how can you get started? Maybe some screen-free coding, maybe some unplugged, as well as a progression of what that can look like, K-12. I'll introduce you to some robot friends, and then I'll tell you more about the districts I work with now and what we're doing for STEM in action. So the next slide is just a quote. I know Hand to Mind likes to collect these quotes of people doing this, using the different products and what their experiences have been. So this is a quote that has you consider coding, not just digital literacy, but like as a language of creativity. I had recently worked with researchers from Harvard that were doing a creativity and coding project, and how coding in general can help kids expand their ability to be creative in other areas as well. And it was just very interesting. So on the next slide, overall, one of the whys for coding, like I said, the digital literacy, right? We want them to know that language of the future of being able to use computers and not just consume, but also create the content. And so along with digital literacy is creativity, right? So kids, if you've seen them using something like Scratch, just like how creative they can be, because they can iterate so easily. They can start with something, test it out, get feedback instantly. That's the awesome part about coding, is that feedback loop is so fast. So kids really are getting creative when they're able to start exercising their coding muscles. And then the problem solving, right? So sometimes we have challenges or tasks, or even the kids will come up with their own. And so they have to decompose it, break it down into step by step. So that problem solving muscle is really getting flexed. And then we also have those math skills, right? So students have to, through their problem solving, figure out a lot of the algorithms, that step-by-step problem solving, or an advanced coding, an if-then sequence that has parameters that might be values greater than, less than a certain amount, or when something else happens. So a lot of really cool math skills can be embedded in coding. And last, really, is that confidence. So when you get to see kids create something through coding a robot and they solve the challenge, their confidence is amazing. That you can see it on their face. And it's because of that iterative nature. Like, they get to test it out, and the failure doesn't feel so big because they get another chance right away. So that's part of the why for coding that I really like to emphasize. In my programs, we've done a lot of those cognitive competencies, right? It's a lot about these skills that are transferable, not just, I know this language. So let's look also at the numbers, right? So the future, even now, a lot of the STEM jobs are going unfilled, and there's going to be a lot more of them. And it doesn't require all of our kids to have to get a 4-year degree or even a 6-year degree or beyond. There are lots of great coding jobs and opportunities for students that the students can learn in high school, and maybe a 2-year degree, and have a really fulfilling, high-paying job. Also, like our high schools, a lot of them don't teach as much computer science. So we want to change that. We want to have more high schools, more students have the opportunity for that, so that we can keep feeding that STEM pipeline. So there are a lot of numbers out there too. You might find more that you've come across as well. So I just wanted to start with thinking about something as like unplugged coding. So typically you might think of coding as like, Scratch or Hour of Code, the programs on the computers. and having to have technology. But Hand to Mine and Learning Resources, the sister company, has this kit that I've used for several years now, um, called Let's Go Code, and it's kinesthetic, right? The kids are signing up, so we were even having the PE teacher use it, and so the kids get into teams and they create the mazes to program each other through. So on the next slide, you can see in one of my classrooms here that the students set up the maze, right? So that maze builder is problem solving. They have to think through, okay, how am I going to set this up with all of the criteria and constraints that I'm given? And then you have the coder who has to sequence the code cards, right? So they have to think step-by-step order. They're using some of their math skills there. And then the robot has to follow the directions. And if the coder makes a mistake, the robot has to provide that error feedback, like, oh, this isn't working, so that they can go back and debug. And so the students, this is a kindergarten class here, are able to think through just that step-by-step order as they're going. And this is something that they are creating, and then we scale it. So in the first slide, you saw a couple other things, but we add in, okay, well, now you have to pick up the screw or the bolt on your way to get to the robot's home. Or now I'm going to give you more math. And so then you have a longer sequence that the students are creating, but it's scaffolded as they go and as they learn more. And so the students, each group is able to go at their own pace to be able to add these additional layers of complexity as they were coding without using any electronics or anything like that. So on the next one, thinking about it overall when we get into this, so whether it's unplugged coding or it's using devices, the standards that we can look at to find the fit for this, of course, you have the computer science standards. A lot of it talks about the algorithm, that's step-by-step instructions and sequences, as well as decomposing a problem, breaking it down. And then you can see elements of that in the CCSS standards. So it's all about the events and the order in which they occurred, as well as ISTE, develop a sequence of steps and automation, because ISTE talks about computational thinking as one of the topics for ISTE, and so I'll tell you a little bit more about computational thinking as we go. On the next one here, just some unplugged coding ideas, like if you don't have anything in your classroom yet, you just want to try it out, maybe you have some manipulatives. You can see kind of those colored shapes there, right? The different shapes. So you could just have students sort the bin of shapes, right? And come up with, either you could provide or the kids could provide, like, okay, how am I going to sort it? So if it has 4 sides, then I'm going to put it to the right, else I put the shape to the left. Or if it's red, put it to the right, else put it to the left. And have them sort it like that picker robot, which is actually the most common type of robot, as one of the industrial robots there. I also, the students found it hilarious to program me to eat a bowl of cereal. So I just had a little mini boxes of cereal, and they had to program me each step. And so if they told me to dump the cereal in before I opened the box, well, I dumped the whole cereal into the bowl. Or if they told me to put milk in, just put a little bit in, because they didn't tell me how much. So we get into the nuances of coding of, you have to be very, very precise and use very, very clear language. For kindergarten, we also did programming me to get dressed for winter. So I put my coat on backwards and my hat and my feet. So we just, again, worked on the sequencing, what order, breaking it down. So some fun ideas for you guys. We want to hear from you now. So Brandy will step back in and help us with this section. But we want to hear from you about how you're incorporating coding into your classroom.
Yep, so we heard from you guys in the poll that some of you are already dabbling. So in the question pane, if you want to go ahead and put in, what are you doing with coding today in your classroom? And while we wait, I can provide at least one example. One example that I've been a part of in the classroom is using it as part of Makerspace. And what I saw is having these different robots available, the scalability of some of them. So in this instance, it was the robot mouse, but watching a fourth grade, all these fourth grade students, they were having a blast because they were making the mouse maze super hard, like very complex maze, almost to the point where they thought it was impossible, right? And then at the end, being able to, you know, somebody else coming in and testing the code and seeing that it did work and it was possible. So really cool to see that scale up into fourth grade on something as that even kindergartners could start with. All right, I have a couple of other ones here. Let's see. We've got um, lots of robots people are using. Botley, Bbot, Ozobots, Scratch, which we've talked a little bit about, doing Hour of Code. We've got people who are, oh, I like this one. I used pony beads and a coding pattern for my students to code their name with beads and make necklaces and bracelets. It's a good one. A middle school teacher, Brian, moving to K5, used code.org dash and dot scratch code academy. I'm hoping to find some options for K5 students in this webinar. Perfect. Scratch Junior, any of these things piquing your interest, Becky, to talk more about Tinker?
Yeah, so I can talk about a lot of those, and I'm actually going to piggyback off the one you were talking about. One of my favorites, really, that we've got a lot of use out of is the robot mouse because of that scalability you're talking about. So the older students, when we're using it, and that's kind of the advantage of like a robot that they get familiar with and that they really know how to code, the kids feel so much more confident, like going above and beyond. So we had them, each group had a small part of the overall large maze that they were coding, and we were coding overall, like I think it was like a space thing where we had to like go pick up different parts at different space stations that we needed in order to get to the final destination. And so each group then decomposed and figured out the exact sequence for each section of the maze, and then they put it all together as a whole class to complete the entire maze. So we really liked the scalability of that as well.
Yep. What did that look like? Like how long did it take? You know, how many class periods, that kind of thing.
Yeah, and so we had created our own. So we love like the maze one, right, with the green faces that we'll show you in a little bit that has the maze walls. But we needed a bigger mat, so we took from the book how far it goes, the robot mouse goes in a certain increment, and we just printed our own grid mat and drew some sections on there, like this is quadrant 1, 2, 3, and 4. And so we had to plan out where each robot was going to start and end so that the next group knew, like, okay, this is where it's coming from for each one, but you have to be able to navigate only using so many moves to get this, to get the square, to get the object that's on there, and then you have to be able to end over here to land over for the next group to pick it up. And so because the students were older for that one, I would say like overall really it was probably about 2 class periods. We have about it was about 40-45 minutes all in all to be able to do that. I think it was probably another half a class period where we were then documenting it. So like I loved using like Seesaw, right, an LMS that we can take video of what's going on, and then the students are able to write about it. We use that as like our engineering notebook, so they could document a little bit ahead of time of what the problem was, and then they could document maybe one of their trials, and we talk about a lot of the growth mindset, right? So a lot about, oh, we figured out that this is what was going wrong, or we noticed this other group was doing this, and that really helped us figure out what to do. So a lot of our reflection is about the process, not just the end result. And then they were able to all take a video of it, like in the end of what the whole thing was. And then, of course, you know, parents can see it and comment on it, and they really appreciate that too.
Awesome. I love it. Weren't you telling me another story too? Maybe that was part of this one that was about like having them peer check the code, just like kind of that it's more of a real world application, but like having them work together to double check the code and kind of and test it, much like typical coding happens for products.
Yeah, well, and you'll find that in the TA standards too about, coding is collaborative. And so sometimes we'll have groups create code for like their own, like I think it was fourth or fifth grade again too, where they were creating their own mazes, but then they had to do it for another group to then like solve it, and then they got feedback on like how well it worked or didn't work. But a lot of the, everything we were doing was in partners and collaboration. I think that's what is so powerful is that the students have somebody to bounce those ideas off of and see how somebody else works as they think through it. But just to really make sure that each student is able to do it and we don't have someone taking over. So we put a lot of structures in place for that too. But yes, the collaborative nature of it.
Awesome. All right, so take us through what this looks like as they progress from a grade level perspective.
Yeah, so you can see like in a lot of different standards, right? There's a progression. So engineering has a progression of, starting out with goals and rules to criteria and constraints, and you'll see that later on in the STEM modules. But for coding, really, as you think about it, those early grades, they're practicing decomposing. That just means breaking down tasks into step-by-step. A lot of kindergartners already write how-to books, right? So we kind of coordinate with that. It's like, oh, right, when you were writing your how to get ready in the morning or how to set the table, that's just like this, right? So we're telling our robot how to get from here to here. And so those steps are, and by the way, a little tip for when you're working with K and 1 that don't know left and right, some of the things we would do is put like a sticker on their hand, either left and right, or a sticker only on their left hand. Of course, we have, them put up their index finger and thumb and do the L, but that doesn't always sink in. So we just try, and then in the end, we let them work it out. But that's some little tips. And then Scratch Garden has a really good left and right song too that we practice raising our hands left and right beforehand. So so step-by-step directions for K1-2. A lot of this, if you're doing an app like Scratch or CodeSpark, it's going to be block-based, right? So then grades 3 through 5, still probably block-based. Some, might start to get into text, but you're incorporating more of conditional coding. So like if then and events and loops, as well as using robots that have sensors. So you'll see in some of the hand-to-my robots like Botley has sensors incorporated, whereas the robot mouse does not have a sensor. It does have a magnet in the nose that it can make a sound when the magnets connect. So there's that little part there, but you can actually use the sensors like in Botley. So that's where we're progressing. In 6-8, you're transitioning to text-based coding. And remember that it's not about the specific language. It's not just we have to teach all of our kids JavaScript. It is about the ideas behind it and thinking through the logic, really, of like how the logic works. And so you're also collecting data and refining the code based on data collection that your program is either running or that if you're using a robot that's doing as well. And then in 9-12, you're really using and understanding fundamental differences between different coding languages. So you are getting more versed in knowing the nuances between different types of languages and choosing the best tool for the application. So whether it's really good for robotics or whether it's really good for software or if it's really good for like design and illustration and gaming types of stuff. So that's kind of a progression you'll see mirrored a lot in the CSTA standards and through some of the products that Hand2My and other people carry to. You'll see that trend. So we want to kind of introduce you to some of our robot friends for all ages. You can kind of see the continuum there from the newest, cutest little puppy there all the way through Artie. So I'm just going to go over a few details about each one. So coding critters. So this one is kind of like the robot mouse, but it's really um, for even younger kids. So like pre-KK, just exploration. There's some little toy things you can see that the robot can interact with. There's just a little storybook. And one thing to know about this one, the robot mouse will do like a point turn. This coding critter does like an arc turn. So when it turns, it actually goes forward and turns versus turns in place. So just a little nuances to know the difference there. But this one's very like storytelling interactive. It's meant for like, a child to be doing it with somebody else at times where there's some back and forth like, oh, look, we're going to roll the ball. Let's see if we can figure out how to get the dog or the cat to get all the way to the toy, and estimating like, okay, how many times do you think you have to press the button to get there? Do you think you have to turn it all? And then just figuring it out as you go. So probably really good for like a little like a center, right? Not that you would necessarily be doing like a whole class of that at a time, but probably really good like for a center for exploration. So Code and Go Mouse, talked a lot about. There's a lot of different companion products around this that are really cool. So if you were using this one, you could really expand the use of it. So there's a math kit to program the robot to go through sequences, like, so there's the cards like 1 through 10, right? So blue forward, if you roll the die that you see there and you get forward 5 and then the operations dice and like, oh, it was a minus, so then that would be yellow backwards 2, right? So the students can model mathematics equations using the robot mouse for that one. Also, there's the game. So you might have heard of like Robot Turtles. It's kind of a unplugged coding game that has been out for a while. Well, so there's Robot Mouse Mania, which is really cool because it's meant for like 4 people can be playing at a time, and the kids can be playing each other. You don't have to have the parent or the adult that is doing the actions for the kid. And so this one is nice for if you have like only like maybe a small set of the robot mice in the classroom, then if you were doing like the robot mouse game as another center for the students, and so then you could rotate through with that one. So I was able to see a lot of kids really enjoy that because it was kind of like they were in charge of all of it when they were doing it, and it was pretty easy to learn how to do. Next, so Botley is the one I was talking about, which it includes sensors. This one, instead of programming directly on the robot, this one you would imagine like he's on the floor because you don't want to drive him off a table, right? This happens. We try not to do that. But then he has a remote control where you can program his turns and direction that he goes. But then he also has object detection. You can actually loop the program. So again, that's getting a little bit more advanced, right? And then you can code the robot to also make sound at the different points in the program that you want. The biggest power with this too is when you're doing it, you always want the students to show the cards, those coding cards that come with it, to show their program, because otherwise, if they're just entering the buttons, they won't be able to remember all of their steps and what they've done. So they have to go back and debug. They won't have a representation of it. So we just created like a grid on a piece of paper that fit the little coding cards. Brandy, can you go back one picture just so I can point out one of them? So the coding cards are over here on the by the robot mouse game. You can see those. So yeah, we just created a grid and just labeled it step 1, step 2, step 3, step 4. So that the kids could keep it organized. And we also do left to right, like we read. You saw like in the Let's Go Code, and you'll see on some other apps, sometimes people do top to top to bottom. That's fine too, as long as kids understand that they're doing one or the other, that it's not just random, that they have a reason for it. So yeah, so with Botley, there's challenges. You can get the this activity set where he can go and act as kind of like a STEM set, force and motion, that he can go and interact with different things, move the different things around, to play kind of like a little playground area. He also takes a lot more commands, so he can have a lot more involved program. And the one thing to know about Botley, with the remote, the transmitter, the infrared transmitter, you have to make sure if you have multiple in the room that you are facing away from a different robot so that it doesn't trigger both at the same time. So we just have kids be spaced out as much as possible, and then facing the robot right there with the remote as close as possible. But he's really fun for some of those math challenges too that you saw kind of with Robot Mouse. I've been able to set up with the activity set some of those same things where you go, forward so many, backwards so many, to end up with your full math equation. And then we have Artie. It's kind of like our creativity robot, right? So I think about when I first was doing Hour of Code, I remember like Frozen was out, and there was the snowflake one, if some of you remember that too, where the kids were doing the entering the numbers in for Elsa to be able to draw the snowflakes on the screen for the little avatar thing, right, that moves around. So Artie's kind of the same idea. So a lot of the different robots, right, like have like different attachments that you can try and add the marker on, or you try and figure that out, but it's not always centered just right. So he was built to be able to have like the marker centered just right so that he can draw all of these really cool designs so that you can program. So there's lots and lots more available for him. And this one does work with a computer or tablet. So whereas the other two are screen free, we would say like this one requires some type of computer or tablet to be able to program him. All right, so thinking about, coding the future. So overall, we want our students to be able to create, right? Not just consume technology. We want to have them innovate. And there's a lot of jobs that don't exist yet. So that's why we're really focusing on these cognitive competencies, or these like skills that, and not about like learning a discrete facts about a specific coding language. We do want them to be problem solvers and innovators and creators. So we do want them to be comfortable within a language or within using a robot. That's where it's nice to have some of them scale and use it multiple years. So one of the things in my current district, we are, right now they have one more robot, a different robot for grade levels, and we're kind of rethinking that. So as I'm coming in and figuring out what's going on in the classroom, it seems like maybe we should repeat some of those so that they get multiple years with it. Because we've seen like in our summer enrichment that if they had it the previous year, the kids could do so much more, and they were so confident that they could go beyond and create more than constantly introducing a new robot. So transitioning from coding then a little bit into thinking about STEM as well. So Handmine has two newer kits in their STEM in Action line. One is about basic needs of animals using Robot Mouse. One is using Botley for minerals and erosion. And so in both, you're completing some different science activities as well as modeling with the robots. So in the K2 one, you're modeling with a mouse how an animal would get its basic needs met, and how it would avoid danger. And so as they go through and learn more about the basic needs of animals, they add on a little bit more layers of the coding that they would use for that one. And then for the robot challenge one, they're collecting minerals and making sure that the robot is the one that's going into the place where, we use a lot of robots to explore places that are either hard to get or can be dangerous for humans. That's where we have rovers on Mars, right? So that's bringing home the idea that you're using a robot to help humans, and that they can be beneficial because then we can protect human life and we can make sure that it's safe. The robot to go and do that before we would ever send a human to go and do it. So lots of real world connection there with the robots. So another module, so like here you can see, I don't know if this is curiosity or opportunity. So one of the Mars rovers, and how we're using it to explore on Mars in space, and that connection. And so there's a really great website that we can share out to. It's from IEEE, and it's about all different types of robots. So, students might think like, oh, it's just, robots in the classroom, and that's, or robots in movies, that we don't really encounter robots in real life. But once they see all these robots in the medical fields or in the military and security, they love those ones. They can carry equipment, or these space ones, or ones that go deep in the ocean, or robots in industry, right, in factories and in warehouses that can help humans and make it a easier job for some humans to do. I think kids start to like connect with it more, like, oh, okay, so there is more to this. It's not just this little robot on my desk. So this guide also, so this is like kind of inside peek of what the materials look like for the STEM in Action Kit. So this one is for teachers. Here you can see kind of the teacher guide really walks you through lots of questions, prompts and things about that for what's included in the different kits. And then for the full line, the next slide there, it's all about the engineering design process, real world problems. So all of these connect to, so whether it's the ones with the coding, with the robots in it, or just our STEM in Action line, based on the NGSS integrated engineering standards, so the STAR standard, right, on the NGSS, they connect to a problem that scientists and engineers are trying to solve. And so the one, and you can see kind of the kit here and all the materials that would be received. So this one is digital relay connection that's being shown. So fourth grade one, based on the standard about waves and transmission. And so they talk about being able to send messages through like fiber optics, and talk about like binary code, or also using other ways to communicate messages efficiently and in secret. So they create a secret code too. On the next one, you can see, so these modules, so I was the developer at Hantamai, but I worked with engineering experts from Purdue University as well as Texas A&M, and so they were beta tested in classrooms. So they were approved by university faculty that are experts on engineering education, as well as the robustness of the science and the math. And there we were very adamant about making sure that the math was not just arbitrary, that it really did connect. And so you can see our engineering design process that we created, that the students go through, and that it is cyclical, right? It's iterative. So we don't always start at define the problem. It might start at seeing and testing a little bit of a model, but then learning about that, and then defining, okay, now overall this is our problem, and this is what we need to do to make a better model. So there are several kits available. This is like a whole line, but they're supplements, right? So they are not meant to be like an entire curriculum that's going to meet all the standards, but they are designed to meet those NGSS STARD standards and the major and the ETS standards, so that all the engineering ones. So you can see though that there's life, earth, and physical all represented from pre-K on up through grade 5. And there's several handouts about these too, I believe, in the handout section, that you'll be able to see more information. So each grade span is just a little bit different. Like pre-K kits are more whole class versus and some small group, but the other ones are a lot more like groups working on things together. up to like 6 groups. So it has all the teacher support materials, hands-on materials, really in the kit. There are refill kits as well, like for some consumables, but a lot of them, like I think we've been using the ones here in these districts for I think like 4 years. And so, over time we just replenish a few of the materials as needed, but the other materials have been able to stand up to classroom use for at least 4 years so far. And then as you go up in grades too, you'll kind of see, right, that the time increases a little bit, so there's more days and there's more time. Like in grades 1, 2, they're solving a problem for a friend. So a friend has a problem like that, they need to take care of a pet. And how do I know what the basic needs of the pet are? Or my dog's muddy and wet, so my mom doesn't want him in the house. How can I create a mat for him to be able to have him dry off on the mat? So I need to know about material properties before he comes to the house. And the student books are available in Spanish as well as the worksheets if you are in a district that needs that. And then the last set, the grades 3-5 module, scales up, right, where we're solving a problem for a client. So it might be the city, or it might be a club, or it might be a industry that you're solving a problem for. So trying to scale up a little bit more. Again, the language, we're talking about criteria and constraints. And this is hands-on materials for up to 6 groups. So you can see again that Botley one there, and it is up to 60 minutes a day. Some days do need the 60 minutes. So, working that in some elementary schedules, but some days are maybe 45 minutes. So thinking through, and we provide some tips for helping do that in the kits as well. It's a little case study here. So just my first year as a director of science, we are part of a intergovernmental agreement with a high school district and a couple of the feeder elementary districts. So my job is to help the elementary districts to be able to articulate and align, and they're smaller districts, so they don't have necessarily their own curriculum department, or one doesn't have coaches. And so to help them develop their programs and provide PD and just make sure that their needs are being met younger, so that by the time they get up to high school, they're ready for these rigorous classes and we can continue to meet their needs. And so right now we have it based on quarter. So in our pre-K, there's a plethora of different pre-K modules that we just do there throughout the year. And then in kindergarten, you can see we start with plant and animal needs with Ron's Habitat. And then you can see each quarter that we have something different there. We also use a Code and Go Robot Mouse module and robot in kindergarten. Just they've really embraced a lot of these kits, and I have to say that my teachers have told me that these are like their favorite part of the curriculum that we're currently doing. Like they really understand it well. It goes very smoothly. And this was something that was in place actually even before I started here, right? It's been 4 years. And so it was kind of cool to come in and see a whole district that's already using all of this materials that I've helped create, and to hear their feedback. So it's really neat to be part of it. I also do a lot of different summer enrichment programs. So we use a couple of those coding ones during the summer. We find it because like those were newer ones, so we didn't have it embedded in our grades yet. So we found like summer was a great chance for teachers to test them out for us and see like what the students were doing, and then like, okay, are there any other supports that we need? Like, what are some nonfiction books that we can put with this? Or what is the math that we want to introduce before we get to this part? So we really have appreciated being able to try it out in the summer and then fit into the year where the teachers feel that it really fits. That's it for
Awesome.
me, Brandy.
Yeah, thank you so much. We have a few more minutes left before we get to questions and Q&A section though. We've got to do our giveaway. So this is a giveaway for a STEM in Action module. We have the K5 coding solution shown here, but of course there's I think over 18 modules to choose from. They're all designed around the engineering design process and made for integration into your curriculum where you have gaps or where you want to focus. So I'm going to pick a winner. And that winner is Virginia Smith. So we have your information from registration and we will contact you and you can start shopping around and figuring out which one you want. Awesome. And we do have a couple of questions that came in during, so we'll do this until we've got 3 minutes to do some Q&A here. So you're on the hot seat. And on here, there's just some examples. If you ever want to see how other people are using STEM in action in their curriculum or in their classrooms, and what that looks like, we're always retweeting and sharing out what that looks like. We get tagged all the time, so it's really fun to see that. All right, so first question. This is about robot clubs. If you've ever created one or if you have any advice for creating or insights into how to do a robot club for elementary students.
Yeah, so a couple of years ago, I tried out the with Dash and Dot, the Wonder League, through their system because I had a challenge and it was free to participate. It was just me, so I had only had 10 students because I thought that was all. Actually, no, I take that back, 15. That was all I could handle, and so it was 5 with each. Really, I recommend, no more than 5 students if you only have one robot for them. Less is better. I've also done First Lego League. With these particular robots too, like I would say, don't feel like you have to be part of something that's existing. Like if you just want to test it out, you could just test out a robot club that just explores the robots that you have or that you want to explore. And then just as you get into it, see some different challenges. Like Brenda was showing on here, if you also search like Twitter, you can see some different challenges people came up with, or like the robot mouse one I was talking about, where they broke it, where we had a large map, then we broke it down. What's nice about like ones that are existing, they provide a lot of the materials and so on for you. But some of it was too hard for my students. Some of them only solved like one challenge because there was so much that we had to get through and learn. So yeah, so my recommendation would be like, if you want to start with just like have it be a robotics club where it's not competitive, they just explore robots. Like I also know a teacher that did like a coding club and he did it over lunch. And so they went through and learned some different coding modules through, I think he was doing like Hour of Code. And then if they passed a certain level, they were able to then get their pilot's license to fly the drone and then be able to fly the drone during lunch. Yeah.
So cool.
So that was kind of fun.
Yeah. Can you talk a little bit more? So you had the modules, they're being done quarterly, and obviously you showed how much time per day. So what does this look like quarterly? How are most of the teachers, or what are the different ways the teachers are integrating those modules into their classroom day?
Yeah, so in our K2, they have 30 minutes daily. I think one of my districts has maybe 3 to 4 days a week, depending, because one has social studies and one doesn't. It's always interesting in elementary with science and how much time you get, right? And so they, during science time, so that's how they're connecting it, and is during the science time about 30 minutes a day, especially for the lower. The upper grades, they get, it is still about that 30 minutes a day, so they have to sometimes double up so it's one day, but then they don't have it the next day. And they have paced it out during the year, so they put it in the quarter that it seemed to fit the best with the math standards that they've already would have gotten to at that point. Some of them do it as the kickoff, like they introduce the problem, but then they get into like science curriculum, so we use different other programs from Pearson and Mystery Science and other things, but then they come back. So they use the STEM in Action module really to like end cap, like beginning and end of their unit. So they introduce it, then they have some more content inside. And I'd have to say, like, even though it says, maybe like 6 to 8 days is like the average. I think my teachers, a lot of them probably push the unit out to like 12 or 15 days just with the other things that they add in
Awesome.
um, to it. So like Farmer Grady with weather, they're exploring more clouds and more extreme weathers, or
Hmm.
um, you know, just doing more with it, but using that kind of to introduce a problem of like where we're going, and then as the application at the end.
I love it. All right, perfect. Well, we are out of time for today. So, um, as a reminder, you're going to get a link to this recording. So that will come if you want to share it with anybody else. You're also, when you leave, going to get a survey. So we'd love your feedback so we can continue to improve on the future events and know what else you want to hear about and what else we can do to help educate you. All of these products are available at handtomind.com/coding. We love social, so please reach out to us on social media, tag us. We want to continue the conversation, and we have Becky's information right there. So thank you, and have a great day.
Thanks, everyone.